Today our focus is looking back again at our unit goal. How can I demonstrate what I know about fractions and decimals by reasoning about their value? Our focus for this lesson is to build upon what you learned in class today. We're going to use a strategy to help us solve problems using equivalent fractions. I want you to think about the problem in front of you. Anaya is planting a flower garden. The garden will have no more than 12 equal sections. 3/4 of the garden will have daisies. What other fractions could represent the part of the garden that will have daisies? I'm going to go back and read this problem again and underline some things to make me understand it a little bit better. I can tell that she's going to make 12 equal sections and that 3/4 of the garden will have daisies. They're asking me for other fractions that could represent the part of the garden that will have daisies. Now let's look and see how we can solve this problem. I know that I need to find the fractions that could represent the part of the garden that will have daisies. I need to know that 3/4 of the garden will have daisies, and the garden will not have any more than 12 equal sections. This is important because I know that if there's no more than 12, then 12 is going to be the highest denominator in my equivalent fractions. How will I use this information? We're going to try making a table to find some equivalent fractions to solve the problem. Let's look and see how they did it in your book. Here, they drew a graph, or they drew a model, of 3/4. Here's the total garden. I can see 3/4. Now, we can say that if we want to make it a little bit different, she could do this. Now she has 1, 2, 3, 4, 5, 6 out of a total of 9. Out of a total of 8. 6/8 is equivalent to 3/4. I can look at another example. Instead of drawing the line here, I might say, I can make it equivalent this way. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 that are daisies, and 12 possible sections. Even though I could continue making different fractions, I'm going to stop here because 12 is the most amount of sections that she's going to have in her garden. So it wouldn't make sense to continue creating equivalent fractions that have a larger denominator. We're going to try another problem. Two friends are knitting scarves. Each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. If the friends are making 10 scarves, how many rectangles do they need? How many will have stripes? I'm going to go back over this question to look at what might be really important to remember. I need to know that each scarf has 3 rectangles because they want to know how many total rectangles will they need when making 10. I need to know that 2/3 of them will have stripes. And I need to know how many rectangles will have stripes. So this question requires me to find 2 answers. I need to know how many total rectangles they need, and I need to know how many stripes will have stripes. Let's see how we can put a table together to help us solve this problem. So now, as we write down the steps, the first thing we're going to do is we are going to create a table. As I make my table, I want you to make it along with me, and please pause the video if I go too fast so you can catch up. I'm going to make a table that will show on the top how many scarves or what number scarf they are making. So for example, as I look at this one, I know that if they are making one scarf, then 2/3 will have stripes. So the bottom one is going to represent stripes. Now if they make 2 scarves, then 4 out of the 6 will be stripes. If they make 3 scarves, then 6 out of 9 will be striped. If they make 4, then I need to know that they will have 8 twelfths. If they make 5, then they will have 10 out of 15. I don't know if you notice what I'm doing here, but I'm multiplying 5 times 2/3. 5 times 2 is 10. 5 times 3 is 15. So now let's see what happens with 6. 6 times 2 is 12, so 12 will be striped. And 6 times 3 is 18. They'll use 18 altogether. When they're using 7, 7 times 2 is 14. 7 times 3 is 21. So they'll use 14 striped and 21 total. For 8, 8 times 2 is 16. And 8 times 3 is 24. So 16 will be striped, and they'll have 24 altogether. If I'm making 9 stripes, or 9 scarves, 9 times 2 is 18. And 9 times 3 is 27. So 18 will be striped, and 27 total. If I'm making 10, I could say 10 times 2 is 20. 10 times 3 is 30. So they will need 20 with stripes, and they will need 30 altogether. Now, I want you to think about this. Could I have thought about what I knew to be able to solve that problem? Let's check it out. If I knew that 2/3 of the stripes would be 2/3 of the rectangles would be striped, and they needed 3 for each scarf. Instead of just making that big long table, I could also have said, if they're making 10 total, I'm going to need 10 of each of these. I'm going to need 20 striped, and I'm going to need 30 altogether. I could have found the answer just by using what I know about multiplication. Let's see if we can use that strategy for this one. Jackie is making a beaded bracelet. The bracelet will have no more than 12 beads. 1/3 of the beads on the bracelet will be green. What other fractions could represent the part of the bracelet that will be green beads? I'm going to go back and underline what I know. I know Jackie's making a bracelet, and there'll be no more than 12 beads on each bracelet. And 1/3 of them are going to be green. The question asks me, what other fractions could represent the part that will be green? In this problem, I'm not seeing her make more and more and more bracelets like the last one. In this problem, I'm seeing that they're asking me for equivalent fractions to 1/3, and that no denominator will be greater than 12 because the bracelets will have no more than 12 beads. So I can make equivalent fractions using 1/3. I can multiply 1 times 2 to get 2, and 3 times 2 to get 6. I can multiply 1 times 3 to get 3, and 3 times 3 to get 9. I could multiply 1 times 3 to get 4, and 3 times 4 to get 12. So I just took my base, and just like the last lesson, I multiplied both the numerator and the denominator by the same number, by 2, by 3, and by 4, to make equivalent fractions. We have one more to do together. What I'd like for you to do, I know that you do not see a pencil here, but I do want you to write. I want you to pause the video and see if you can solve this problem on your own. Let's see what we need to do. All right, he's making bagels, and each package is going to have no more than 16. So that's going to be my greatest denominator. I know that 3/4 are in each package are plain. And they're asking me other fractions that could represent the ones that are plain. So they're asking me for equivalent fractions. I'm looking for equivalent fractions for 3/4. I'm going to multiply 3/4 times 2 to get 6/8. I'm going to multiply 3/4 times 3 to get 9/12. And I'm going to multiply 3/4 times 4 to get 12/16. And now I found the other fractions that could represent 3/4. Not going greater than 16 because that's the total amount of bagels. Well, you guys did a great job. I know problem solving is never easy, and I'm really, really proud that you gave this a good whirl. Now your job is to go and complete the quiz for this section. And remember that we must see the work that you do. It is impossible to do some of these in your heads. I know you maniacs think you can, but trust me, you cannot. So there needs to be some work shown to show that there is some effort besides just pressing a button and deciding what the answer is. We really want to know what you know. So good luck, and we'll see you tomorrow at school.